Okay, I'm going to make this a little shorter today. We'll just do part of investigation 9.2.1. If we were in class, the activity that we would have been doing is kind of like this human number line where we would have lined up kind of across the room. Each of you guys would do it with a different number, and then we would have identified whether you would be a solution to a possible inequality or not. So if you look at 9.2.1, it kind of talks about this activity. Okay, so this human number line. So because we're going to make the transition in the second half of chapter 9 from moving with quadratics equations to now looking at inequalities. Now, it's probably been quite a while since you've done any inequality work. You might have done a little bit last year in 7th grade. We haven't done a lot with it this year. And it's kind of popped up in the homework a little bit, and then probably in 6th grade you probably did some of this graphing that I think when we do this it'll kind of jog your memory on what it looks like. Okay, so here's our first inequality. So if you want to kind of follow along and print this sheet out, or you could just make your own number line, but we're going to look at some different possible things that would make things true. So I'm going to look at this first inequality, which was x is greater than or equal to -2. So let's think about what that means. So x is greater than or equal to -2. So first I'm just going to look at things that are actually solutions to this, okay? So if I put -10 in here, would that be greater than or equal to -2? No. How about 9? No. 8? No. 7? No. What's the first number on my number line that's actually greater than or equal to -2? Well, the first number that's true for is actually -2. Okay, how about -1? Yeah, that's true. 0, okay, 1, 2, okay. So all of these numbers are actually greater than or equal to -2. Now, what if I said, how about 0.5? Is that greater than or equal to -2? So that would have been a yes too, okay. If I'd said negative, let's see, 1.999, would that have been greater than or equal to -2? Yes, it would be. So actually any number -2 or higher would actually make this inequality true. Okay, so I'm going to include -2, and then I'm going to shade any number on here, okay, to show a picture of like all the possible numbers that are greater than or equal to -2. Okay, so the second one says, what are the numbers that are what numbers are less than or equal to 1? Okay, so let's kind of look at that same thing again. Okay, so and again, if we were in class, I would have had each person in class take one of these numbers, and then if it was true for you, you would have held up that sign, and then we'd start to look and see some patterns. Okay, but what numbers on this number line are actually less than or equal to 1? So is -10 less than or equal to 1? Sure it is. How about -9? Yes. Okay, so I'm going to just color in every number that's less than or equal to -1. Okay. All right, so this one is also, okay, is 2 less than or equal to -1? No, it's not. So I'm not going to include anything past this point. Okay. How about 0.5? Is that less than or equal to 1? Yeah, it is. Okay. So I'm going to include anything from this boundary point of -1 or below would make this true. Okay. So I'm just going to show this with shading. So here's a picture of all of the possible solutions to all the possible numbers that are less than or equal to 1. Okay, so let's look at C. It says, give me a number, x, that's equal to 3. Okay, unlike those first two inequalities, this is an equality. So what number is equal to 3? The only thing on this number line that satisfies that is just the number 3. Okay, so that's a single solution to that one, unlike an inequality that actually has an infinite amount of solutions. Okay, so how about D here? What are some numbers that are greater than or equal to 0? So same thing, go ahead and go on the number line, and any number that's actually true for, you go ahead and identify that and see what pattern you see. Okay, so you should have noticed that none of these numbers, first number that's actually greater than or equal to 0 is 0. All these numbers over here would work. Okay, and I could keep going on my number line, so I'm just going to go ahead and shade this because I could have the decimals in between, and then I'm going to make an arrow to show that I can keep going. Okay, so let's go ahead and take a look at E. E says, tell me the numbers that are equal to -2. Okay, so the only number equal to -2 on here is just -2, so that's the only thing I'd identify. Okay, so F says, what are the numbers? So tell me a number that is greater than or equal to -1, but less than or equal to 4. Okay, so I'm going to go across here as -11 or 10 fit in here. Well, -10 is less than 4, but it's not also greater than -1. How about -9? Well, it fits this one, but not this one at the same time. So it has to fit both of those. Okay, so the first number on here that would actually be a solution would be -1. Okay, 0 would also fit. 1 would fit. 2, 3, okay, and 4. 3.5 would fit. 2.1 would fit. Anything between -1 to 4 would actually be solutions. Okay, so I'm going to go ahead and shade that like that. Okay, so notice how it looks a little bit different when I have what's called a compound inequality. So x has to be greater than a particular number, but also less than another one. Okay, so you kind of see a difference here in the way it's graphed. Okay, so this one says, now this is kind of pulling us back to what we did with some quadratic work, but this says x squared is greater than or equal to 4. So give me a number that when squared is greater than or equal to 4. Okay, so I'm going to start down here. Would -10 work? -10 squared. Is that greater than or equal to 4? Sure, because that's going to be 100, isn't it? How about -9? Yep, because that's going to be 81. Okay, -8 times -8 also would work. Okay, is every number going to work, or am I going to get to some that actually don't work? Okay, -2 works. -2 squared is actually 4. Not 1. -1 squared is 1. 0 does not work. 1 does not work, but 2 does. Okay, 3, because I'm going to get 4, 9, etc. Okay, so actually, this would look kind of different than the other ones. These are the numbers that actually work. Numbers that are greater than 2 or less than -2 would be my picture of those possible solutions. Okay. All right, this one, the last one says, give me numbers that are less than -3. Okay, any number on the number line that's less than -3. So I'm going to start just saying, going across what works. Is -10 less than -3? Sure. -9, -8, -7, -6, -5, -4. Is -3 less than -3? It's not, it's equal to it, okay? So is -2 less than -3? It's not either. Okay, so I'm not going to plot anything over here past -3, but could I have actually put like -3.1 in there? Is that actually less than -3? Sure. Okay. How about -3.001? Would that be less than -3? Okay, I could get infinitely close to the number -3. So the way that I'm going to show that graphically is I'm going to put an open circle on -3. Okay, because I'm not going to include that one, but I'm going to include anything less than that. Okay, so think about how that graph looked different than all the ones above. Okay. Okay. So, and then I'm going to end the ed puzzle by asking you just a few more questions. Okay. I'm probably kind of based on the last couple questions in here, but that should give you a primer of what we're thinking about when we're graphing and solving inequalities, thinking about what kinds of numbers will work.